Welcome back to another video with Teacher Dacre. So welcome. Alright, we'll be looking at ratio and we're going to tune in on unit rate. So we're going to be specific about unit rate. Alright, remember ratio is when we compare two numbers. What am I saying about ratio when we compare two numbers? For example, we have a class of students and there are 10 students in that class. 7 are boys and 3 are girls. So we can compare the ratio, boys to girls or girls to boys. Or we can compare girls to the entire class or boys to the entire class. Alright? So we'll be comparing two numbers there. Alright? But for a unit rate is when we compare two different units. But when we compare two different units, one of the unit has to be 1. The word unit means 1. In other words, if you should write the unit rate or the rate as a fraction, the denominator must be 1. Alright? Alright, here I have an example. A top swimmer would be able to swim across a 25-meter pool in about 1/5 of a minute. How fast can a top swimmer go? So we want to find how fast can the top swimmer go. We know that the swimmer can go about 25 meters in 1/5 of a minute. So how fast, when you're normally comparing how fast a person can go, we're normally comparing the amount of distance they can cover in a certain time, alright? And it's best to calculate here. How fast can that swimmer go in maybe a minute? Because when we say 1/5 of a minute, it may cause a little challenge to us. But if we should think about it, how fast can the swimmer go in 1 minute? Alright, so we are going to find how fast can the swimmer go in a minute. Let's go. We know that the swimmer can go 25 meters in 1/5 minute. Am I going to use MIN for minute? Alright. We want to find out how fast the swimmer, we are going to set this as a proportion. How fast the swimmer can go in a minute. So 1 minute is what we want to find out. Why did I put the minute in the denominator? The minute is in the denominator here. It is also in the denominator here. So meters is in the numerator here. We want to find how much meters can you cover in a minute. So that is what we want to find. So that will be your unknown. We use a variable to represent our unknown. Let's continue. Now that we have it set out, we are going to cross multiply. 1/5 multiplied by x is equal to, we have 25 multiplied by 1. 1/5 times x is 1/5 x. 25 times 1, that's going to give us 25. Remember, we want to find what 1 of the x would be equal to. This is 1/5 of the x is equal to 25. So, to find what 1 of the x is equal to, we can multiply both sides of the equal sign by 5 to get rid of this 5. In other words, we are multiplying by the opposite or the flip of the fraction. So we multiply this side by 5. We also multiply this side by 5. The 5 would cancel here. We are only left with 1x, which is the same thing as x. 25 times 5, that's 125 minutes. So what is this saying? It is saying that a top swimmer can cover, not minutes, but meters, sorry. What is this is saying? It is saying that a top swimmer can cover 125 meters in 1 minute. So can cover 125 meters in 1 minute. I am also going to show you a different method that we could use to solve this. Okay, so it's the same question, but I'm going to show you how to solve it differently. Alright, so we want to know per minute. Alright, we want to know per minute. How fast is it that the top swimmer can go per minute? So since we want to know per minute, that's the unit we want to find. So anyone that we want to find the per for or 1 of, that is the one that goes in the denominator. So 25 meters would go in the numerator and 1/5 would go in the denominator. What is this fraction telling us? This is a complex fraction that we have here. This fraction is saying 25 meters divided by 1/5 of a minute. So it says 25 divided by 1/5. So this is saying 25 divided by 1/5. Alright? Remember, any whole number we can write it as a fraction by putting a 1 under that whole number. It does not change the value of the number. So 25, we can write it as a fraction by putting a 1 under it. How do we solve a fraction? To solve a fraction, we say we keep the first fraction, change the division sign to multiplication, and we flip the fraction that follows the division sign. 25 times 5, we multiply straight across. So 25 times 5, that's going to give us 125 meters. 1 times 1 is going to give us 1. Alright, so it's the same thing, 125 meters. So once you know the one that you want to be the unit rate, or you want to be 1, that's the one that goes in the denominator, and then the other one would go in the numerator. And I'm going to try another question so you can see what I'm talking about. Okay, another example. A school janitor has mopped 1/3 of a classroom in 5 minutes. At what rate is he mopping the classroom per minute? So we want to find out how much of the classroom would he mop in a minute, or how much of a classroom would he mop in a minute. So since we want to know per minute here, how much did he mop per minute? So the minutes would be in the denominator because we want to know per means 1. So we want to know per minute. Alright, so it would be 1/3 over 5. Alright, be 1/3 over 5. What is this fraction saying to us? This is saying 1/3 divided by 5, which is equal to, remember dividing fraction, we can change whole number to a fraction. We change division sign to multiplication, and we flip. So this becomes 1/5. 1 times 1 is 1. 3 times 5 is 50. So he can mop 1/5 of the class in a minute. He can mop 1/5 of the class in a minute. (1/15) of the class room per minute. So he can mop 1/5 of the classroom per minute. Alright, that will be the answer. 1 over 15 per minute. That's what he can do. 1 over 15 per minute. We can also work this problem. Same problem. We can also work the same problem by setting it as a proportion. So the 1/3 goes in the numerator still. The 5 goes in the denominator. We want to know per minute. So that's the unit rate. So 1 goes there. And x, we want to know how much of the classroom we can map in 1 minute. We can cross multiply. 5 multiplied by x is equal to, let's do 1/3 multiplied by 1. 5 times x is 5x equal to 1/3, because 1 times 1/3 is going to give us 1/3. Alright? To get rid, we want to know what 1 of the x would equal to. So to get this coefficient to be 1, we have to divide by 5, sorry. We divide this side by 5, we also have to divide this side by 5. 5 would cancel 5 there. X is equal to 1/3. When we divide in fraction, what do? Can change that to a whole number, a fraction. We keep, we change, and we flip. Same 1 over 15. So you can map 1 over 15 of the class in 1 minute. Alright? So you can map 1 over 15 of the class per minute. Okay, third example here. It says Shelly's cup of tea cooled down in 1/2 of a degree in 10 minutes. At what rate is her tea cooling per minute? Key thing here again, per minute. Since we want to know per minute, minute goes in the denominator. It tells you want to know per minute. Which per mean 1. So whichever one you want to know 1 of, that's the one that goes in the denominator. So here the minutes would go in the denominator. So you'd write it as the ratio as a fraction. So 1/2 over 10 minutes. So the minutes goes in the denominator. So how fast would her tea cool in 1 minute? Let's find out how fast it would cool. 1/2, what is this saying? This is saying 1/2 divided by 10. And remember, we can write any whole number as a fraction by putting a 1 underneath that whole number. When we are dividing fractions, we keep the fraction before the division sign. We change the division sign to multiplication, and we flip the fraction that follows the division sign. Multiplying fractions, all we need to do is to multiply straight across. 1 times 1, 1. 2 times 10, that's 20. So what is this saying? This is saying that Shelly's tea would cool 1 over 20 degrees per minute. That's what it is saying. So her tea would cool in 1 over 20 degrees per minute. Alright, so remember, I said that there are 2 ways we can solve it. So any of the way that we are comfortable with, we can work with that way. Anyone we work with, that's going to give us the same result. Alright? Alright, so we said that whichever we set it at a ratio, since we want to find per minute, that goes in the denominator. So 1/2 and 10 minutes. we're setting it as a proportion. So we want to find out per minute, that meaning 1 minute, per mean 1. How fast would her tea cools per minute? So let's cross, multiply, once we set it as a proportion, 10 multiplied by x is equal to 1/2 times 1. So 10 times x, we are cross multiplying 10x, 1/2 times 1, that's what we have there. 10 times x, 10x, 1/2 times 1, going to give us 1/2. Alright? Remember, the aim is to find out what one of the x is equal to. So what we're going to do, we're going to divide by 10 to find out what x is equal to. Anything you do to one side, you have to do to the other side. 10 cancel 10. We are only left with x. On this side, we are dividing. We can change the whole number to a fraction. When you're dividing a fraction, you keep the fraction before the division sign, change the division sign to multiplication, and flip the fraction that follows the sign. Multiplying fraction, we multiply numerator with numerator. 1 times 1, 1. 2 times 20, 2 times 10, sorry, it will give us 20. Alright? So 1/20. Any of the method we use is the same procedure. Same answer, same result. Alright, this is the final example that I'll be doing. This is example 4, and then I'll stop for this one. Alright? A baby kitten gained 120 grams of weight in 1/3 of a month. If the baby kitten kept growing at this rate, how much weight would he gain in 1 month? First question, you want to ask yourself, what is it they want to find the unit rate of? So you want to find in 1 month, how much would the baby kitten gain? How much weight he will gain in 1 month? So what you do, since you want to find out per month or in 1 month, you know the month would go in the denominator. So if we should write this as a fraction in the ratio form, write this as a ratio, in the fraction form, it will be 120 over 1/3 month. And I write MTH for month, and this is gram. Alright? What is that telling us? This is saying 120 divided by 1/3. That's what it is saying. You can change a whole number to a fraction by putting a 1 under it. When you're dividing a fraction, you keep the fraction that comes before the division sign. So this remains as 120 over 1. And you change the division sign to multiplication. Then you flip the one that follows the sign. So flip the fraction that follows the sign. That now becomes 3 over 1. When you're multiplying fractions, all you need to do is to multiply numerator with numerator and denominator with denominator. 120 times 3. That's going to give me 360. So the baby kitten, the mitten, would gain 360 grams in 1 month. Alright, the other method we can do, first we write it as a ratio in fraction form. So we want to find per month. So month would go in the denominator. So we have 120 over 1/3. You will want to find out with 1 month. So month, 1 month, that's the unit we want to find out. So that's 1 month. This would be month. and this would be gram. We use G for gram. We want to find out how much will the baby kitten weigh in 1 month. So next is for us to cross multiply. So we have 1/3 times x is equal to 120 times 1. 1/3 times x is 1/3 x. 120 times 1 is 120. We want to find what one of the x is equal to. So we need to get rid of the 1/3 here. In order to get rid of the 1/3, you multiply it by the reciprocal of the fraction. So once it's a fraction, you multiply it by the reciprocal of the fraction. So we're going to multiply by 3, or 3 over 1 is the same thing. Alright? Anything you multiply by one side, you have to multiply the other side. So we have to multiply 120 by 3. 3 will cancel 3 here. We're only left with x. 120 times 3 still give us 360. So that's 360 grams. So the kitten, or the baby kitten, would gain 360 grams in 1 month. Alright, thank you for watching. Ensure you like, you leave a comment, and share, tell a friend to and ensure you subscribe. Have yourself a wonderful time. Till the next time.